The product and quotient rules for differentiation. Which of the following is a product of two functions? Okay, the first one. We've got x squared and we've got a to the power of x. Two functions, we're multiplying them, so this is the product of two functions. The second one, we've got a log term here, that's a single function, so this is not the product of two functions. The third one, the sine, and this is the angle, it's a sine function, just like this was just a log function, nothing else, this is just a sine function. Again, this is not the product of two functions. The fourth one here, we've got a log function here, and we've got x cubed. This is the product of two functions. This one here, 2t, is a function, and 1 minus t to the power of 3 is a function. We're multiplying them. It's the product of two functions. This one here, that's a single function there. That's not the product of two functions. This one here, we've got an exponential function here, and we've got r. This is the product of two functions. And the last one here, this is an exponential. This is not the product of two functions. For there to be a product of two functions, you should be able to write the first function as u and the second one as v, and quite clearly in between you should be able to put a multiplication symbol there. So you're clearly multiplying two separate functions like this. You see, you can't do that with this e to the power of sine 2x. I can't write that as something and then clearly times something else. But this one I can. This one you can't. This one here you can. You've got this function here times this function here. Down here we have this function times this function. Here you've got sine of some angle. You cannot write it in this form. You can't put sine times something. That would be just meaningless. This one here, again, you can't put in, you've got your log there and then 2x. If you were to do this, the log of what times 2x? It doesn't make sense. So this is not the product of two functions. This one is. For all of these, we can use the product rule for differentiation to differentiate these. And that's what we're going to focus on here. So let's say that y is equal to some function u of x times some function v of x, and more conveniently that's written as just y is equal to u times v. Then dy by dx is equal to function u times the derivative of v plus function v times the derivative of u. Now you may find it more useful to actually memorize this the other way around, like this. V times du by dx plus u times dv by dx. The reason for this, and this is jumping ahead slightly, when we go on to looking at functions which can be written as a division, like one function divided by another one, we'll come across something called the quotient rule for differentiation, which is simply all of this but I'm going to change that plus to a minus. But can you see these terms are in the right order, and then you divide by v squared. It's just easier to remember these in this form. I mean, this is the quotient rule. You can't move these terms around in the quotient rule. It is exactly what you see here. But it's easier to relate this to the formula for the product rule when the terms are written in the same order. Okay, so for the time being I don't need any of this. Okay, so to differentiate this, that's my function u, this is my function v, u is equal to x, and v is equal to e to the power of x, and then differentiate each one, so du by dx is equal to 1, and dv by dx is equal to e to the x. And then looking at the formula, I'm now just going to cross multiply. So if I multiply these two, plus cross multiplying these two, and this is what dy by dx is equal to. Clearly we can simplify this, you don't need the 1 there and all the brackets, so it's just e to the x plus x times e to the x, and if you want to factorize you can write it like this, e to the x 1 plus x. Okay, so all I've done here is I've just applied the standard formula. Doesn't matter if you had this term on this side or this on this side, doesn't matter, you're just adding them together. And as you can see, v du by dx, there's v, and there's du by dx, so you're just cross multiplying. U times dv by dx, there's the u, there's dv by dx, you're multiplying those two, so again you're cross multiplying with this method. So if you lay out your working out like this, so you put u on the left, v on the right, and then you differentiate each one underneath, you then just cross multiply and add the terms together. It's that easy. Okay, so using this product rule, we're going to differentiate this product here of two functions. Okay, so using the product rule for differentiation, we're going to differentiate the product of these two functions here, x times e to the power of 2x. So the one on the left is function u, the one on the right is v. So u is equal to x and v is equal to e to the power of 2x. And this is exactly the way you should lay out your working out. Put u on the left, v on the right, and then differentiate each one underneath like this. So differentiate x, you get 1, differentiate e to the power of 2x, you get 2 e to the power of 2x. And now looking at the product rule, which looks fairly complicated, but you've got v and then you've got du by dx. Well, there's the v, there's the du by dx. All it's saying is just cross multiply like this. See, there's the second part there, u dv by dx, there's u, there's dv by dx, and what are you doing in between these two? You're multiplying. So you just cross multiply here, u times dv by dx. Okay, so these two multiplied. So it was v first, times du by dx. So this is all dy by dx at this point, which is this, plus u dv dx, u dv dx, so cross multiplying here. It's good practice to use brackets, and then you can remove the brackets when you're simplifying. So these two multiplied give e to the 2x, plus, and this will be 2x e to the 2x, and if you want to you can factorize this like this. It may be useful for something else. Okay, so that's the derivative of x times e to the 2x using the product rule. Okay, next example, we're going to differentiate ln x times x cubed. So on the left that's function u, on the right that's function v. So as before, put the u on the left, v on the right, differentiate each one. We're just following the product rule here, make sure you memorize this, it's not in the formula book. So 1 over x and 3x squared here, and as you know, we're now going to cross multiply. So these two multiplied, and then these two multiplied. Simplifying here, x squared plus 3x squared ln x. You may find this factorized form more useful. For instance, let's say if you were looking for stationary points, and you know that dy by dx is equal to 0 for a stationary point, so then you've got this. And then you think, alright, so for what value of x will we get a stationary point? And from here you might think x squared, when x squared is 0, so x equals 0 could give you a stationary point. X equals 0, can you really have the log of 0? You can't, so you can't have that one. Then you've got 1 plus 3 ln x, and if you make that equal to 0, so then you've got this. So then you've got this. Take the 1 over, and then to work out the value of x there, if you do exponentials on each side, so then you're doing e to the power of there, so that your x is equal to e to the power of minus a third. And that's the decimal value for e to the power of minus a third, 0.716. If we have a look at the graph for this function here, you can clearly see the stationary point here. That's x equals 1 here. That's about 0.7 something right there, x equals 0.7 for that stationary point, which is exactly what we've just worked out by doing this and this on the calculator. And that's why this factorized form can be useful when you're looking for stationary points. Okay, moving on to dividing functions of x, which leads to the quotient rule of differentiation. Now the word quotient just means the result of a division. For example, 6 divided by 3 has a quotient of 2. It's just the result of division. Now what we're looking for specifically here is the division of two functions. Let's look at the first one. E to the power of x is a function of x, and we're dividing that by another function of x. So this is the division of two functions of x. Next one, k is equal to ln r divided by r, and once again you have a function of r here, and you have another function underneath. So this is the division of two functions. Yeah, two functions of r in this case. This was two functions of x. Okay, next one, we've got a constant divided by a function of x. Okay, so there's just a single function here. You could write this as 5 x to the power of minus 3 and then differentiate this. This is not a division of two functions, and for the same reason the next one is also not the division of two functions. You have a single function there. Again, you can write g of x there as equal to 2, that 2 there, here, times 2 minus 3x. This was to the power of 1, so this will be to the power of minus 1. Okay, the next one here, you've got a function divided by another one. So we are dividing two different functions of x here. The next one along, we have a function of x there, and we're dividing by another function of x. So in all of these, if you can write something as a function called u, like u of x, divided by another function v, then we can use the quotient rule for differentiation. So that would apply here, that would be u, that would be v, it would apply here, that's u, that's v. It would still work here if you wanted to apply the quotient rule, but it's more sensible to write it like this and to differentiate using an alternative method. The same thing's true again here. If you wrote this as u and this as v, it would still work out, but it's easier to just write it like this and then differentiate using an alternative method. This one counts, that's u, that's v, and this one counts, that's u, and that's v. Okay, so y is equal to u of x, so some function u of x divided by some function v of x, and we can simplify that to just u over v. Now the product rule for differentiation was this, and to modify this into the quotient rule, what you're going to do is this. You're going to divide everything here by v squared, and that plus there becomes a minus. Okay, that's quite simple. But remember that you must start with v du by dx along the top here. Okay, so using the quotient rule, we're going to divide this. You need to memorize the quotient rule, it's not given to you in the formula book. So e to the power of 3x, that's u, and v is x squared, so if we write these like this, and then differentiate each one, so du by dx is equal to 3e to the 3x, and dv by dx is equal to 2x, and then dy by dx, and this is just applying this quotient rule now, v du dx, so we're cross multiplying like this, and that's always a minus in between, and you're cross multiplying like this. And remember, the whole thing is divided by v squared, and v was what, x squared, so v squared will be x to the power of 4. I'm going to simplify by cancelling some x terms, because there's an x term here, here and here, so then we've got, we can cancel a single x from each of these, so 3x e to the 3x minus 2e to the 3x over x cubed. And then I'll factorise, because there's an e to the 3x here and here. I've taken that out, I've taken the x cubed out. That leaves the 3x minus 2 inside. Okay, dividing x squared, which is u, and this is v, so u is equal to x squared, and then you differentiate, and then you do the same with the log term there. And then cross multiply. That's always a minus here. Cross multiply. All divided by v squared. This is v, so v squared is the log term in brackets squared, like this. Now be careful here. V squared, if you think it's equal to this, it's not. Because what you're doing is v is equal to ln x, So let's do it with brackets. I'll put brackets on each side, so that's a nothing so far. Now I'm going to square both sides. So v squared is equal to then x squared. And when you're simplifying, make sure you don't write this. It's not equal to that. That's the way it stays. That 2 does not come to the front. That 2 only comes to the front if it was written like this. Now the 2 can come to the front to give you this. But it wasn't this in the first place. Okay, so that's the way v squared remains. It's not this or any of this. And then simplifying, the x squared times the 1 over x will give us x here. There's an x in both terms there, so we could write it like this. Okay, so there you go, the product rule for differentiation and the quotient rule for differentiation. And the product rule, the standard way that you'll see it written in textbooks, is commonly like this. It's like it's in alphabetical order. You got U there and then V here. But because you're adding these together, it doesn't make any difference in which order you write them. And this is easier to remember because this term and this term in the quotient rule and this term and this term, they're in the same order. So all you do to the product rule is you change the plus to a minus and you divide by v squared and you've got the quotient rule. Neither of these are in the formula book, so memorize them.